Morning, Brodie. Today is May 7th, Wednesday. And you had homework. We're going to check it, so get that out. You should have already done your probes, updated the board, moved your B if you mastered anything, get flashcards if you need them. Should have already done that. I'm going to set a timer. There is a lot to cover. Okay. A lot to cover the next 2 days. So let's get on it. Don't forget cursive. You need to have that done by Monday. All those pages. Remember, your cursive is dated. Okay. So Anna and Jennifer both bought a small turkey sandwich. Anna ate half of her sandwich, and Jennifer ate 3/8 of her sandwich. Which ate more? Draw a picture to prove your thinking. So you should definitely draw 2 sandwiches of the same size. So I will try my best. It's not good at drawing. So we'll assume those are the same size. Label one Anna, one Jennifer. If they're side by side, that's fine. I just did it this way so I can tell if I've made them the right size, the equal size. Anna ate half. So here's Anna's half that she ate. And Jennifer ate 3/8. So let's do 8s. So cut it in half to match Anna's. That's another reason why I do it on top of each other like that. And then we're doing 8s. So there's 4ths. And then you need 8s. So we cut those in half. 4 times 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And she ate 3/8. 1, 2, 3. So according to our picture, Jennifer needs to eat another 8 to match Anna's. Half of 8 is equal to 4. So who ate more? Oops. Anna ate more. So Anna ate more. Because she ate half of her sandwich. So 1/2 equals 4/8. 1/2 equals 4/8. And Jennifer ate 3/8. Make sure you have all that information. Pause the video if I went too fast for you. Alex played for 2/3 of the soccer game. Christian played for 2/4 of the same soccer game. Who played longer? Draw a picture. So on this, I recommended that you would do a number line to show like duration of time, because a soccer game lasts however long in time, and they have to be the same length. If you didn't do this, make sure you're making corrections with a pen, one of my grading pens. Okay, so label for each person. Alex played for 2/3, so you need to split this up into thirds. So I'm going to draw a little dotted line so I can see the half. So this is about 1/3. 1/3, 2/3. And plot the 2/3 with a dot. Christian played 2/4. So half, half. So now I have fourths. 1/4, 2/4, 3/4. I have to put my 0 in you should have something like that. And 2/4 is here. And it asks, who played longer? Well, Alex played longer because 2 is more than half of 3. 2 is half of 4. So Alex played longer. 2 is more than half of 3. 2 is half of 4. So make sure you write that down. 2 is more than half of 3. 2 is half of 4. So make sure you organize it like that. Pause the video and make those corrections if you need to. Again, make sure he's making these corrections, because a lot of times if I'm standing up here, I can't really tell what he's doing over there. Just make sure he's following along. The Thompson family ate 3/4 of a large pizza. So Thompson and the Smith, I was born with that last name, Smith. They're eating 3/4 of a medium. So a large pizza is bigger than a medium. So you should have a large circle over here on Thompson and a smaller circle on Smith. So it says the Thompson family ate 3/4 of a large pizza. So split this into fourths, a little plus sign or cross, and shade 3/4 of it. And then the Smith family ate 3/4 of the medium pizza. Did the families eat the same amount of pizza? Well, the answer is no. The large pizza is bigger in size. Therefore, the pieces are bigger than the medium pieces. Sorry, my pen is just like really smearing a little bit. So pause the video if you need to write this. So no, the large pizza is bigger in size, therefore the pieces are bigger than the medium pieces. Yep, if you have a whole that's bigger, the whole pizza is bigger than the other pizza, it doesn't matter if they ate the same portion of 3/4, because this pizza's slices are bigger than this over here. Okay, so make sure you have all that written down. If you need to use a sticky note or something because you made a lot of error, you're having a hard time writing over it with the pen, you can use a sticky note. All right, now we're going to watch a video about equivalent fractions.
What up, everybody? It's Dr. B back again here with another fraction lesson. Today we're going to be talking about what are equivalent fractions. We hear about them all the time, but what in the world does that really mean? So let's build it up with our objective today. Our objective today I will be able to understand what it means when fractions are equivalent. So what is equivalent, right? Being equivalent means that two things have the same value or are equal. So when I think about equivalence, I think about this scale right here. Some people call it a balance, okay? And we know that whatever's on balanced anymore. But let's go back to this balance that is equal to each other, right? And we've been doing a lot of things with equivalence for a long time. For instance, we know that if you put 2 plus 2 over here, and you had a 4 on this side, these would be balanced, right? They would be equivalent. 2 plus 2 is equivalent or equal to 4. But if I erase that 4 and put a 5 over on this side, it would become unbalanced very quickly because 5 is more than 2 plus 2, right? They aren't balanced, so my scale would tip. So I cannot say that 2 plus 2 equals 5 because it's not true, right? They are not equivalent. So you guys already knew that with whole numbers, but you might not have thought about equivalence in fractions very much, but it's the exact same thing. Let's clear the board and get our balanced scale back. So what does it mean for fractions to be equivalent, right? It's really the same thing that we just looked at with whole numbers. Let's take a look at our balance right here to see what I mean. So here is one whole candy bar, okay? And I got a candy bar, and Kenny got a candy bar, okay? They're the same exact size candy bar, same chocolate, same everything. Now I want to split my candy bar in half. And so I cut it right in the middle, and you can see right there I labeled my unit fractions that build my whole, right? I have 1/2 here and 1/2 here. Now Kenny wanted to split his candy bar into 6. And so Kenny did that, and you can see that his unit fraction obviously would be 1/6 because 1/6 is what one of these parts is equal to. So he has 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. And so he equally split his into 6. Now, I wasn't very hungry, and so I didn't want to eat the whole candy bar at one time. The question is, how many pieces of Kenny's candy bar would he have to eat to have eaten the same value or the same amount of chocolate that I've eaten? Remember, he cut his into 6, so his pieces are a lot smaller than my pieces. So now that they're next to each other, right, hopefully it's a little bit easier to see. How many pieces of Kenny's candy bar would he have to eat to be equal or to eat the same amount of chocolate that I had? Well, obviously it's not 1 because his one piece is a lot smaller than my one piece, right? He split his into 6 pieces, so that makes a lot of sense. He split his into smaller pieces. So let's give him another piece. So if we gave him 2 6, you can still see that that's not the same value as 1/2. If he eats 2 6 and I eat 1/2 of my chocolate bar, we don't have the same amount of chocolate in our stomach. So let's give him one more. It looks like he's only 1 piece away from being equal to me. There you go. And you can very clearly see then, if he ate 3 of his pieces, he ate the same amount that I ate. In other words, if we put both of these fractional pieces onto the scale would be balanced. They are equal to each other. So mathematically what we would write is 1/2 of my chocolate bar was equivalent to 3/6 of his chocolate bar. Because remember, the numerator tells us how many unit fractions we need to build this fraction. So both of these fractions represent the same amount of the whole. I just needed more 1/6 because when I split it into 6, my pieces were smaller, right? My unit fraction of 1/6 is smaller than my unit fraction of 1/2, so I needed more of them. I really love this example because it leads us into our key thought, which is to be called equivalent, fractions don't need to be written with the same numbers. They have to represent the same value. So going back to look at this, 1/2 doesn't look the same as 3/6, right? The numbers are different. In fact, they mean different things. But 1/2 represents this much of my chocolate bar, and 3/6 represented the exact same amount of candy bar, right? That's what equivalent fractions are. Fractions that represent the same amount of your whole. So because math can't always be chocolate bars and pizza, right? It can be food all the time, although we love food at here in Instructed Eats. Let's take a look at what this might look like mathematically. A lot of times we use fraction strips to help us understand fractions. So here's one whole, okay? And here's 1/4 of that whole. If I broke this whole into fourths, this is what one of those parts would look like. This is a my fraction 3/4, right? My numerator of 3 told me I needed 3 unit fractions to build this. Now, what happens if I took this one whole again and split it into 8 or 8 equal parts? One of those pieces would look like this, right? This is 1/8. This is my unit fraction. Or if I split my whole into 8 equal pieces, each piece would be worth this size. Now, the question I want to answer is, can I build a fraction with the denominator of 8, right? So using my 1/8, that is equivalent to 3/4. Is that even possible? So instead of using the scale, I'm using my equal sign, right? Because that's what we use to represent the scale in math. So let's start by using my 1/8, right, my unit fraction, to build a fraction so I can represent the same amount with 8 that I did with 3/4. And I'm going to space them out just a little bit so you kind of very clearly see how many 8s I needed. But really, they're right next to each other. So here's 2 8s, right? And I can see that 2 8s would be equivalent or the same size as 1/4. So using that knowledge, I can see that, hey, I can build a piece that is the same size as 3/4 using 8s because I just need 2 for each of my 1/4. So here I have 4 8s, and I can see that 4 8s are equivalent to 2/4, so I need 2 more 8s. And then you can see right here that I could build a fraction using my 1/8 that it was equivalent to 3/4. So if I have 6 8s, right, if I use 6 unit fractions that have a value of 1/8, that is equal to or the same size as 3/4 or 3 unit fractions of 1/4. These are equivalent fractions. They would be balanced on our scale. All right, so we're going to do a U-try. Now, I've given you all the fraction scripts kind of together, so that way, because you might not have them with you, and that's okay, right? So you can use this to kind of estimate if you need to, because I know you're looking at a screen. But what I want to figure out, first of all, is it possible to build a fraction that is equivalent to 2/3 using 6? So come down here, and here's your unit fraction for 6. How many 6s would I need, if it's even possible, to make something that is equivalent to 2 of my thirds? Go ahead and pause the video right now and see if you can use the fraction strips right here to figure that out. Write it down on your paper and then push play to check your work. So hopefully you just did, and you can see right here that if I had 2/3, I would need 2 of these unit fractions put together, and that if I have 4 6, that these are equivalent. These are the same size. So 2/3 is equivalent to 4 6. So let's do one more together. What I want to know is, can you build a fraction that is equivalent to 7 8, right? So 7 of my 1/8, right? Using your unit fraction 1/3. So can you take your 1/3 and make it equivalent to 7 8? Go ahead and pause the video, try it out, and then push play to check your work. So hopefully you just paused it and you tried it. And so here I have 7 8. That would be 7 of my unit fraction 1/8 put together. You can see right here it'd be about this size. In fact, let me go ahead and outline that in red. This is a bit easier to see. There we go. So that would be 7 8. And here's my 1/3. And if you look at it, I cannot build a fraction using thirds that is equivalent to 7 8. Because 2/3 would be right here. That would not be the same size. It wouldn't be equal on our balance. And if I kept going, my next 1/3 would make me equivalent to 1 whole, and that is not equal. So I cannot make a fraction using thirds that is equivalent to 7 8. So I want to bring us back to our key thought. To be equivalent, fractions do not need to be written with the same numbers, right? They have to represent the same value. That's what equivalent fractions are. Fractions that can be written differently that represent the same amount of the whole. Thank you so much for checking us out today. We really appreciate it. We know there's lots of different options online. Please check out instructabeats.com for.
Alright, so that gives you a little bit of information about fractions of equivalency. So back in your notebook, I just realized as I was going through some things in group 3's notebook, you guys are on the same spot. So this video will also be used for group 3. So sorry if I confuse you in any way, but there's no sense in me recording 2 videos exactly alike. I honestly don't have time to do that because I haven't even packed for my trip. And it is Friday night, 11:41 p.m. So almost midnight. And I haven't packed, and I leave tomorrow night. So it's going to be interesting. Okay? So we are on this page where it says equivalent fractions. Write 1 or more equivalent fractions under each flap. The possibilities really are endless. So I want you to write the fraction that is on the flap first on all of these. So go ahead and do that. Oh, I didn't cut that, did I? Let me cut my page. Alright. 1/2, 2/6. And you'll see why we're writing these in a moment. Okay. So what number or what fraction would be equivalent to 1/4? Well, I introduced this a little bit already, and we can see it starts with the unit fraction. It starts with 1, so we can't divide anything to get equivalency that way, but we can multiply the numerator and denominator by something to get an equivalent fraction. I'm just going to pick 2. If we multiply the numerator by 2, we also have to multiply the denominator by 2, and we get 2/8. And we can check ourselves by asking how many times will 2 go into 8, and it's 4 times. How many times will 2 go in itself, and it's 1 time. So that is equivalent. 2/3. All right, let's multiply by a different number because 2/3, 2 cannot go into 3, so we know that this is in the simplest term. It cannot go any lower, so we have to do some multiplying. Multiply the numerator by the same number as the denominator. So 2 times 3, 6. 3 times 3 is 9. And if we do the opposite and divide 6 by 3, you get 2. If we do 9 divided by 3, you get 3. So we are correct. One-third. 1 is a unit fraction, so that is the simplest term. It cannot go any lower. So let's multiply by 4. 1 times 4 is 4. 3 times 4 is 12. And we can check ourselves. 4 divided by 4 is 1. 12 divided by 4 is 3. So make sure you have all those notes in there, even the multiplication stuff. If you need more time, make sure you always pause the video and write what you need to write. 1/2 is in the simplest form, lowest term. So we can do some multiplying. We already did 2, 3, and 4. So now let's try 5. 5 times 1 is 5. 2 times 5 is 10. And if we ask ourselves, what is 5 divided by 5? We get 1. What is 10 divided by 5? We get 2. Remember, we always do the opposite to check ourselves. If you're multiplying, then you divide. If you're dividing, you're multiplying to check. 2, 6. Oh, here we go. So 2 can go into 6. So let's divide. 2 divided by 2 is 1. 6 divided by 2 is 3. You can do the opposite to check yourself. 2 times 1 is 2. 2 times 3 is 6. Let's see how I'm doing my time. 3 over 4, that is in the simplest lowest term. So now we'll have to do some multiplying. We've already done 2, 3, 4, 5, so now let's do 6. 3 times 6 is 18. 4 times 6 is 24. And we can check by saying 18 divided by 6 is 3. 24 divided by 6 is 4. So that is equivalent fractions. Remember, whatever you do to the numerator, you do to the denominator and vice versa. Alright. Let's look at this page. Rolling equivalent fractions. So you'll need, you won't need any dice because we're doing this like right now. I don't know where the other one is. It's going to be hard to do it with one die. Look in here. That's odd because I had 2 the other day. But this thing is messy. Alright, well I'm just going to pick some random numbers. Okay? And that way we don't have to stay within numbers 1 through 6. Alright. Says roll a dice. We're just going to pick random numbers, write the numbers rolled, make a fraction, making the larger number the denominator, and the smaller number the numerator, make equivalent fractions. So let's start with 2/5. Oh, my bad. Don't fill out these first 2 because we're not using dice. 2/5. Equivalent fraction is in the simplest term, so we'll just multiply by a number. It can be any number. Make sure you do the top and the bottom. 2 times 2 is 4. 5 times 2 is 10. Next, 4/16. Can 4 go into 16? It sure can, so we're going to divide by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. Remember, you can do the opposite to check. 4 divided by 2 is 2. 10 divided by 2 is 5. 1 times 4 is 4. 4 times 4 is 16. Always recommend checking. 7/9. Definitely not going to go any lower. Can't divide 7 by 9 or 9 by 7. So let's multiply by 3. Doesn't matter which number you multiply by as long as you do the same to the top and bottom. 7 times 3 is 21. 9 times 3 is 27. And you can check. 21 divided by 3 is 7. 27 divided by 3 is 9. Next, 6/18. Ask yourself, can 6 go into 18? And the answer is yes, so we can divide by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. 1 times 6 is 6. 3 times 6 is 18. So those are equivalent fractions. All right. we are going to have to stop there, and then the next video will be about fraction of a whole number and making mixed numbers and improper fractions. Alright. Well, you have a great rest of the day. And I will see you in the next, well, you'll see me in the next video.